ellipse and we're asked to find the coordinates of the foci. Okay, actually, I think they might be here. 0 square root of 13. But let's find them for real here. Okay, the focal length can be determined through this equation here. It's focal length squared equals the major radius squared minus the minor radius squared. And I can show you what those are here. So if we have an ellipse where it's bigger on the y-axis like this one, then there's foci that are here or here. Okay, so this would be a focal length, the distance between the foci and the origin. The major radius is the distance from the. It depends, you know. For this one, the major radius is the y-axis, is on the y-axis. But if it was, you know, elongated on the x-axis, if it was, you know, the horizontal axis had a longer part of the ellipse, then this would be the major radius. Okay, so that depends on what type of which one of the two ellipses you have. So the major radius would be this part right here, the distance from the top to the origin, and then the minor radius obviously would be this distance right here. So we can plug all that information into the equation. It definitely looks like 0 squared root of 13 is what we need. But the radius for the major radius it stops at 7, so 7 is our major radius. And then the minor radius, we go to 6 on the x-axis. So 49 minus 36 gives us 13, so indeed square root of 13. That's the dot that goes here. So what are the coordinates? They've already spelled it. 0 square root of 13 and 0 negative square root of 13. Okay, but in case you weren't able to get the foci before, that's how you'd find them. Okay, you find the length, which is the distance from the origin to the foci, and then you use that length and the major axis, meaning the longer axis, to determine where the foci are. Okay.